We talked a little bit about acids and what acids were, and as you remember, acids had to do with H plus. H plus equals acids. And there are two different kinds of acids, and I thought I would clarify this real quick. A strong acid versus a weak acid. Now, a strong acid. Now, normally people think the power of an acid is the same thing as a strong acid or a weak acid, and that's not necessarily the case. A strong acid is an acid that will ionize completely, which basically comes down to where all of the parts will turn into pieces and have charged particles. So say, for example, we had HCl, hydrochloric acid. Well, the two pieces would break apart into H plus and Cl minus. And 100% of this stuff will turn into that stuff. 100%. Now, a weak acid is characterized by something that will ionize, sort of. So if you have, let's say, acetic acid, which is the acid that's in vinegar, so C2H3O, I think it's O2, and so it will do this. Like it will kind of do this and then kind of go back. So some of the H's will pop off, and some of this acetate will, kind of cruise over here and have a negative charge. But then it goes back because it's a weak acid and it's only partially ionized. Now, just to be clear, weak acids and strong acids both do the same thing. And here's a list of strong acids. You got hydrochloric acid. This is nitric acid. This is sulfuric acid, and put the acid part on there. And this is phosphoric acid, ACID. Phosphoric acid. You notice that when you name the acids, like you got nitric and it has nitrogen. Sulfuric, and guess what? It has sulfur. Phosphoric, and guess what? It has phosphorus. And while these guys here will all ionize 100% into broken pieces, where this will be H plus and this will be HPO4 minus 1, and this guy would be, an H would pop off 100%, and then this would be H would pop off 100%, and then this would be NO3 minus 1. So there's 100% break apart. Now these, not so much. How much do they break apart? Well, it sort of depends on the acid. The reaction, they call it ionization rate constant, and that's a big long word. It basically means that based on the temperature and concentration, a certain percentage of these will pop off. So this is hydrofluoric, fluoric acid. Just like this was hydrochloric acid, this is fluorine and hydrofluoric acid. This is acetic acid, and this is citric acid, actually. This is the stuff that's in lemons and oranges that makes them a little bit more acidic and stuff. So that was kind of cool. Now, when you put it in water, just like any other acid, a weak acid will ionize. Like that H will pop off and become an H plus. It just doesn't happen as often. And so, in which case, it will come back. And so, maybe 1 out of every 10,000 molecules will actually have the H pop off, which is not a lot. So that's probably where it comes from. It's like, well, that's really weak. It's weak representation. So both types release an H. A strong acid will release an H plus, which is no different than the H plus that the weak acids release. The only difference is that 100% of the atoms, the 100% of the possible hydrogen ions that can be released are released, whereas here there's a very low percentage, and it's usually less than 1%. So that's kind of the difference. If you have any other questions or things that you want to just kind of like talk about in terms of weak and strong acids, or if you just want to say, hey, is this a weak acid or is this a strong one, find the director. He knows what's happening. As for me, I have a beautiful brunette waiting for me upstairs. I gotta go.